Hello, this is a video tutorial explaining how to draw boxes in two-point perspective. Remember that in one-point perspective we can see the front-facing side of one of the objects. So that means that one side of the object will be completely front-facing. And what that basically means when you think about it is that the horizontal and the vertical parts of that box and the horizontal and vertical parts of the entire box as it is in perspective will be pretty much straight up and down. So your horizontals will stay nice and horizontal and your verticals stay nice and vertical, and only one set of parallel edges that are moving away from you will go to one vanishing point. The difference is in two-point perspective you have two sets of parallel edges, each going to a vanishing point. And additionally, none of the sides of the box are front-facing. So here we have one side that's front-facing, and over here we have no sides front-facing. The other thing you can think about is that in one-point perspective, while both the horizontals and the verticals remain perfectly horizontal and perfectly vertical, in two-point perspective only one or the other remains perfectly in line. So in this case we have verticals that are perfectly vertical, but we do not have any horizontals that are perfectly horizontal. So only one dimension is going to be straight up and down and not moving away from you, and the other two dimensions move away from you into perspective to two vanishing points. So how do we go about constructing objects in two-point perspective? Okay, so as always you start out by establishing your horizon line, and then you establish your vanishing points. So because this is two-point perspective, of course we have two vanishing points, one on either side on the horizon line. So what's the first step to draw an object in two-point perspective? I would just start out by drawing a vertical edge, because if we're going to draw a box sitting on the ground plane, then we know it's going to have verticals. But as we know, it will not have any horizontals that are perfectly horizontal. Instead, all of the other edges will go to either vanishing point. So the top left-hand edge and the bottom left-hand edge are parallel to one another and go to the left-hand point. The top right-hand edge and the bottom right-hand edge are parallel to one another, and as they move away from us into the distance, they appear to meet at the right-hand vanishing point. What about the side? We can safely say that the side of an object that is vertical is parallel to our initial vertical side of the object. So it's going to just be straight up and down, and so will the side of the object on this side. Okay. Now the top part of the object, how do we establish the top edge? The top back edge over here is in reality parallel to this front side edge over here. So it will move to the same vanishing point as the front side edge. And then we have one more edge here in the back, which is parallel to this front top edge here, and so it goes to the same vanishing point as this edge here. So it's a matter of thinking about what edges are parallel to what edges in reality, and so that's how you keep in mind the mantra of perspective, which is that parallel edges that are moving away from you recede to the same vanishing point. Okay, so in this case we have two sets of parallel edges going to two vanishing points. I'm going to draw another box in two-point perspective, and this time I'm going to show you how to add a gabled or a pitched roof to it, since that's something you will need to do for the homework assignment. So again, I'm going to start by establishing our vertical, and this box I'm going to put here and make it cross the horizon line. And then of course these edges are parallel and move away to the right. These edges are parallel to each other and appear to move away and vanish to the left. And then I can decide how deep I want this box to go, how far back I want it to go. I'm going to cut it off right here. I'm going to cut off this side back here. So we can see that a little better. Let me just make those lines a little darker. Alright, now how do we add a roof to this? The important thing to know is that most gabled or pitched roofs have a peak, and one side is a triangle and the other side is a rectangle. So it's like a triangular prism basically. It's what you're drawing. But how do you figure out where the peak of the rectangular prism is? To do that, you need to find where the middle of the side is, of the side of the building. Now, if I just look at the this edge right here, I can sort of find, if I just measure this edge here, I could find where the midpoint is on this line and place it approximately there. That seems to be about halfway. But that's not going to be exactly where halfway would be on the side of this box, because the side of this box is in perspective. So you have to think about what happens to vertical lines as they move closer to a vanishing point in perspective. The easiest thing to think about with regards to that is to think about a fence or a row of trees. And we know that not only, if this was a row of trees, would the trees appear to get shorter, but they would also appear to move closer and closer and closer together the further away they moved and the closer they got to the vanishing point. So the same thing goes for these vertical edges. This vertical edge here and this vertical edge here. These vertical edges will appear to move closer and closer together even if they're evenly spaced. So you cannot just come along and arbitrarily decide where you think halfway is, because that might not be exactly where it is. You have to establish it accurately, and the method for doing that is to use what's called what I just call the crosshair method. And that is to draw a cross across the side of the box to establish where the middle is going to be in perspective. And as you can see, it's very different from where we guesstimated the side of the box would be in perspective. Okay, so that will establish the peak of your roof, and then the triangle comes down to the corners from that peak. Okay, now these edges of the triangle do not go to a vanishing point because they are not parallel to anything else, so they do not need a vanishing point. Okay. However, the top edge of the roof does need a vanishing point. And so, again, ask yourself, okay, so to establish whether it goes to the right hand or the left hand vanishing point, you think to yourself, what edge is it parallel to? Well, it's pretty simple if you think about it. It's parallel to the top edge of the roof right here, which goes to the left hand vanishing point. So the very top of the roof will go to that left hand vanishing point also. And then to establish the back edge of the roof, just think about what edge it's parallel to, as always, and we know that it's parallel to this front side of the triangle here. So if it's parallel to this edge, then it just needs to be straight and in line with that edge, because we do not need to establish a vanishing point for those edges. Okay, just the edges that are parallel to our box shape. All right. So that is how you would add a roof to this particular box shape. And just know that you always do have to use the crosshair method if you want to find the middle of something. You can't just eyeball it, because the middle, as we know, objects that move closer to the vanishing point, further away from us, they are going to appear to move closer and closer together. And so that is very important for establishing the correct perspective.